3, 2, 1.
Hello, my lovely 8th graders. Today we're going to review 8P1.2. So the first thing we're going to talk about is atomic number and atomic mass. So let's start with elements. You know elements, they make up the periodic table. There's over 100 of them. They can't be broken down into smaller parts. Then we have atomic number, okay? So the atomic number, again, is the same as the number of protons in the nucleus of the atom. So in here, the protons are in red. They would be the same as the atomic number. Now, atomic mass is a little bit different. Usually on the periodic table, that is on the bottom. And that's the number of protons and neutrons that make up the atom. So how to find the number of neutrons? You have to take the atomic mass minus the atomic number, and it equals the number of neutrons. So think man. Here's just another slide that's showing the exact same thing. So up here in this little formula, the N equals the number of neutrons, and that equals the atomic mass minus the atomic number. So in this example, they have the atomic mass is 11, so they probably rounded it. Minus the atomic number is 5. Your number of neutrons would be 6. But remember the atomic number too, so this means that that atom would have 5 protons and 5 electrons. Okay, so we need to talk about periods, groups, families, and valence electrons. Valence electrons are something new for you, so we'll go through that one a little bit slower. But we'll start with periods. So periods are the horizontal, so like the x-axis on a graph. So the periods are the horizontal rows on the periodic table. So they would go through and there'd be an increasing atomic number. But that's about all that those would necessarily have. They don't have much in common. Whereas groups or families, think about just like these pictures of these twins, they're alike. Just like you have things in common with people in like your group of people you hang out with or your family, the vertical or the Y, the columns in the periodic table, they have similar properties. Okay, so valence electrons is just the outer shell electron that's associated with the atom, and these are what are going to be combined with other atoms in chemical bonds if that shell isn't closed. Okay, so again, they're the electrons in the outermost energy level, and they're important because these are the ones that will bond. So when we have H2O, like in water, that's the part of the hydrogen that's going to bond with the other hydrogen and oxygen. Okay, so one thing that you guys do need to know is how many electrons that can fit in each shell. So the first string is going to have 2, and then the next string is going to have 8, and then 8, and then the last one that's not on this picture will be 18. You guys probably won't ever get any bigger than that. All right, we have metals, nonmetals, metalloids. So metals are just, they're a solid material usually. They're shiny, they're hard, they're malleable, they're ductile. We'll talk about those words in a minute. And they're good conductors of electricity and heat. Some examples would be like iron, gold, silver, copper, aluminum. Okay, so nonmetals are the exact opposite of a metal. They are very brittle and they are also very dull, not shiny like a metal. And then metalloids are like an in-between. They have some things that are like metals and some things that are like nonmetals. All right, so ductile, just like this kid has got his eating pants on that he can stretch out. Ductile just means that you can stretch it without it getting damaged. And again, remember, metals are ductile. They're also malleable. And malleable just means that you can hammer it or press it without it breaking as well. All right, luster is just how shiny something is. So metals are usually very shiny. Think of like aluminum foil even, whereas a nonmetal is very dull. It's not shiny. And the last thing, when we talk about the groups or families, so noble gases, they're in group 18 on the periodic table, and these are non-reactive. That's important to remember. And the reason why they're non-reactive is because all of their valence electrons, so all of the electrons in their outer shells, are full. And so if you look at this periodic table right here, you can see that most of the elements are metals. There's a few that are metalloids, and then a little bit more than the number of metalloids that are nonmetals, but most of the periodic table are metals. I hope this helps.